Okay, now for the thermodynamics, thermodynamics is the branch of the physical sciences that treats of various phenomena of energy and the related properties of matter, especially the laws of the transformation of heat into other forms of energy and vice versa. Okay, thermodynamics. Branch of physical science that deals various phenomena of energy. And the related properties of matter, especially the laws of transformation of heat into other forms of energy and vice versa. Now, under the thermodynamics, we have the Newton's law of motion, specifically the second law of motion of Newton's. Okay. According to the second law, it states that the acceleration is directly proportional to the force and inversely proportional to the mass. That is the reason we have force is equal to mass times the acceleration over k, where k is the force constant. K is the proportionality constant. Proportionality constant. Okay. Where K is equal to 1 gram mass, centimeter, gram mass, centimeter per dyne second squared. Or K is also equal to 1 kilogram mass, meter per kilogram force, Newton, kilogram to eh. Kilogram mass mag. Kilogram mass, Newton, second squared. And K is equal to 1 slug, feet, pound force, second squared. Then the system of units where K is not unity. Next. Okay. Now, we have K is equal to 32.174 pound mass, feet per pound force, second squared. Or equal to 980.66 gram mass, centimeter per gram force, second squared. Or 9.8066 kilogram mass, meter per kilogram force, second squared. Okay. Now, relation between kilogram force and Newton. Okay. Yung kanina natin, we have K is equal to 1 kilogram mass, meter per Newton second squared, while K is equal to 9.8066 kilogram mass, meter per kilogram force second squared, where 1 kilogram force is equal to 9.8066 newtons, while 1 slug is equal to 32.174 pound mass. Now, for the force is equal to mass times the acceleration over K. From that formula, we can say that the acceleration is equal to force times the proportionality constant over m, where m is the mass. Now, we have the mass and weight. Of course, there's a big difference between mass and weight. Okay. Okay, the mass is the Absolute, the mass of a body is the absolute quantity of matter. Absolute quantity of matter in it. Weight, while weight is the gravitational attraction between the earth and the body. Okay. That is the reason we have weight is equal to mass times gravity over k. But we have the constant value for the acceleration due to gravity. That is 9.8 meter per second squared. 980 centimeter per second squared, or kasi yung gravity natin is 9.8066 meter per second squared. Kaya you have 980.66 centimeter per second squared. And then for the English, you have 32.174 feet per second squared. Okay, from this one, we can say that your mass is equal to WK over G. Or you have W over G is equal to MK. While sa force, we can say that your force over A is equal to M over K. Remember that the mass never changes, only the weight because of the gravity. Kaya kung anong weight mo sa Earth, the same, kung anong mass mo sa Earth, the same ng mass mo sa Moon. Ang nag-iiba is the weight because of the gravity. Then, okay, we have now the formula. And always remember, at or near the surface of the Earth, at or near the surface of the Earth, at or near the surface of the Earth, K, which is the proportionality constant, and G, which is the gravity acceleration due to gravity, are numerically equal. Okay. Then, okay. Let us proceed now for the density. Density. Density is the ratio of mass and volume. Okay. The symbol for the density is rho. Okay. That is the ratio of mass over the volume. That is why we have density is equal to mass over the volume. The symbol for the volume is capital V. Where M is the mass and V is the volume. What are the units of mass? You have kilogram mass, gram mass, slug, pound mass. Okay, for the volume, you have cubic meter, cubic centimeter, millimeter cube, cubic feet, cubic inch, okay, and so on. Okay, then we have now the specific volume, the specific volume. The symbol is small letter b. Now, the specific volume is the ratio of the volume of and mass. Okay, specific volume is equal to volume over the mass. V, volume. M is mass. Small letter v is the specific volume, while the specific weight specific weight is the ratio of weight and volume. Okay, we have specific weight is equal to weight over the volume. But weight is mass times gravity over K all over the volume. But mass over the volume is density. Okay? Therefore, that is also equal to density times the gravity over K. We have three formulas for the specific weight over the volume, but the weight is mass times gravity over K, while mass over the volume is density. That is why we have density, gravity over K. Okay. Let us try to solve this one. Example. Okay, let us try to solve this one. Okay, the specific weight of the object are 7 centimeter by 16 centimeter. Okay. The specific weight of an object is 5.8 kilonewton per cubic meter. Determine letter A, the mass density. Letter B, mass of the object if the dimension are 7 centimeter by 17 centimeter by 9 centimeter. And letter C, specific volume. And letter D, specific gravity. Now, the requirement, the given is, we have the force, the specific weight. Okay, specific weight. Specific weight is 5.8 kilonewton per cubic meter. The constant value for the gravity that we're going to use, we have 9.81 since the gravity is 9.8006 meter per second squared. For letter A, the requirement is the density. Okay, what formula are we going to use? We have specific weight is equal to given specific weight, gravity, then the density. We have rho g over k. Now, using that equation, we can say that the density is equal to specific weight multiplied by k over the gravity, where the density now is equal to 5.8 kilonewtons. That is 5.8 times 10 to the third power Newton over cubic meter. And then the proportionality constant, since this one is in Newton, 1 kilogram mass meter per Newton second squared over the gravity of 9.81 meter per second squared. Cancel Newton, meter per second squared. Therefore, the density is cubic meter per kilogram mass. Kilogram mass per cubic meter, tama. Meter per second squared, meter per second squared. Okay, the value. Okay, now the value for the density is 591.23 kilogram mass per cubic meter. Okay. For letter B, the requirement is the mass. Okay. From the formula of your density is equal to mass over the volume. Since given, we have the given value for the volume, which is equal to 7 by 17 by 9. 7 by 17 by 9 centimeter cube. Okay, mass. Okay, given equation, density mass over the volume, the mass is equal to density times the volume. The density is equal to 591.23 kilogram mass per cubic meter over times multiplied by the volume of 7 by 17 by 9 cubic centimeter. But if you notice, the unit of your density is in cubic meter. Therefore, you have to convert your cubic centimeter to cubic meter. 1 meter is equal to 100 centimeter cube. Okay, now for the mass, we have 0.633, 3 decimal places. Okay, kilogram mass. Okay. Now, for the next, you have to look for the specific volume. Okay, the specific volume is volume over the mass. But if you notice, volume over the mass is also equal to 1 over mass over the volume. But mass over the volume is density. Therefore, this one is 1 over the density. Okay, equal to 1. The density is 591.23 kilogram mass per cubic meter. Okay, this one's 591.23. 0.23. 591.23. Okay, for the specific volume, that is equal to 1.691 times 10 to the negative 3 cubic meter per kilogram mass. Letter D, the requirement is the specific gravity. Letter D, specific gravity. The specific gravity is equal to the density of the substance over the density of the water at 4 degrees Celsius. Okay. The density of the substance is, okay, always remember that the density of water at 4 degree Celsius is equal to 1,000 kilogram per cubic meter, or that is also 62.4 pound mass per cubic feet. Specific weight of the substance. Specific weight of the substance over the specific weight of water at 4 degrees Celsius. Value of the density of the substance, that is what? 591.23. 591.23 kilogram mass per cubic meter. Then the specific weight of the water, which is 1,000. Constant yan 1,000 kilogram per cubic meter. Yes, specific gravity is equal to 0.591